All right. Hello, everyone. Okay, let's begin with our class. So, today we will discuss the homework that I have assigned to all of you from the previous class. Okay, let's start. Okay, take out your exercise books and take out your student book. This was actually on page 66 and 67 of your student book 6. Okay, and take out your exercise book to check your answers. Those correct, you can mark, but make sure you can use any colors except for red. Red is my color. If you don't have the answer for certain questions, you can take mine. Okay, I would like to ask help from the teachers. Can you all please make sure they don't come into the class empty-handed, because some students might not do anything, so which I really don't like. So you can pause this video 5 to 10 minutes. Make sure they do at least 1 or 2 questions. Okay, thank you so much, teachers. Okay, once you guys are ready, we'll proceed. Okay, shall we begin? It is possible, right? Okay. Now, friction. Let's recap. What is friction, class? Okay, friction is when two surfaces come in contact. So that two surfaces, of course, they are not gonna be very smooth surface, nevertheless. Okay, they will become like rough. They have hooves and ridges. So because of that, they come in contact and they will cause a friction, which we call cause a force, which we call friction. Okay, number 1. The question is, rub your finger lightly and quickly across your desk. Okay, what do you notice? You'll notice that your fingers or your hands slowly gets warmer. Okay, due to the friction of the two surfaces. That's the answer. Or you can put anything along the line of my answer. Okay. All right. Number 2. What happens if you rub harder? That means if you take your fingers and you put against your desk right now, you can try do it like on a faster motion. What happens? Of course, obviously your fingers or your hand gets much warmer. Okay, now have you wondered why it gets warmer? Like why does it cause this like warm feeling? It's because now two surfaces, when they are in contact with each other, of course they'll cause friction, right? Okay, this friction also causes heat energy to come along. So heat energy in returns make your hands or fingers become warmer. That is why. Okay, so far so good. If I'm going too fast, you guys can pause me, like pause my video. Okay, number 3. What is the direction of the pushing force compared with the direction of the friction? That means, in what way does the pushing force directs to, and what way does the direction of the friction heading to? Okay, the answer is the pushing force is acting forward. It's always forward, because when you push something, you don't push them backwards, right? If you push them backwards, means you are pulling that thing. Okay, so pushing force is always forward. Sorry. Okay, excuse me. All right. In return, the friction is acting in the opposite direction to the pushing force. So again, I repeat, the pushing force is acting forward. That means, let's say, for example, let me take a different color pen. Let's say we take any of our students. Okay, I won't name who, but okay, I'll just draw a stickman. Sally wants to push a table. Okay, imagine this is a table, right? My table is so cute. Okay, now when the teacher asks, okay, student A, please push the table this side. Okay, he also will push the table. Of course, he'll push the table forward because he's pushing, not pulling, right? So when he pushes this is the pushing force. Okay, push. Okay. Now, when he pushes this, of course, he's pushing against a surface. So this surface is another type of texture in which is different from the legs of the table. So of course it will cause friction, and friction will always act on the opposite direction. Okay, friction. Let me just write that. Okay, friction. So this is what it means by the pushing force is acting forward and the friction is acting on the opposite direction from the pushing force. Okay, so far so good? Okay. Let's go. Question number 4. What happens when the pushing force becomes greater than the force of the gravity? I think all of you already know this because I've already told this in a previous class. Okay. So the answer is the object will start to move forward. Always remember. Okay, let me take my pen. Okay, let's say the pushing force. Okay, pushing P. My handwriting is so bad right now. Pushing. Okay, you know what? Let me just type that now. Sometimes the annotation is a bit confusing. Pushing, if it's greater than the friction, okay, if it's greater than friction, it will cause the box to move. Okay, it will cause the box to move only when it is greater. So the object will eventually start to move forward. This is because the stronger force causes the box to move. Only when you have pushing bigger, of course, it will be able to move. Okay, I will stop here 1 minute for anyone who wants to write down the answers. Okay, all right, let's continue. Okay, let me clear my screen. Okay, let's continue. Okay, question 5, 6, and 7. Okay, number 5. What surfaces come into contact when you apply the brakes of a bicycle? So the answer is the metal rim of the wheel comes into contact with the rubber pads of the brakes. Okay, the metal rim of the wheel comes into contact with the rubber pads of the brake. Right, that's answer number 5. Number 6. What happens to the speed of the bicycle when you apply the brakes and why? I think this is rather using some common sense. Of course, when you apply brakes, the whole objective or why people have brakes on bicycles is to reduce its speed. So that means the bike will eventually slow down. Okay, so the answer is the bike slows down. Okay, then friction reduces the speed of the turning wheel. Okay, the bike slows down and the friction reduces the speed of the turning wheel. Okay, that's number 6. Number 6 is done. Okay, number 7. Why does the bicycle stop suddenly when you apply the brakes really hard? Okay, now the friction is greater than the force of the movement in the wheel. So it stops the movement immediately. Okay, the friction is greater. Remember earlier this now. Only when you want to push something forward, you need the pushing force to be greater. But if you want something to stop completely, you need the friction to be greater. Okay? So that is number 7. Okay, I'll stop here 1 minute for those who wants to take note of what is shown here. All right. Okay. If I'm going too fast, you guys can pause this video and then y'all can take note of the answers. Okay. Let me continue. All right. So we've already finished topic 4.4, energy and movement. We've already discussed. And then we've already talked about topic 4.5, which was friction. And we had our homework and we discussed the homework. Okay. Now, let's recap of all the forces that we are already learned. We are going to learn so that it looks better in a bigger picture. Okay, now I want to take out your exercise books. I mean, you already have your exercise books on the tables, right? Okay, do this in your exercise book. This is to show you the different type of forces, which is contact forces and non-contact forces. So we will be learning all of this. That means, okay, for example, now so far we've already learned applied force. So applied force is already done. Okay, spring force is already done too. Remember the spring balance? Okay, that is it. Drag force is after this, which is air resistance. Okay, which is air resistance. Frictional force, we already done, which was today and the previous class. Normal force, which is push and pull and all that, we already learned that when in energy and movement, the topic energy and movement. Okay, magnetic force coming soon. Electric force also coming soon. Gravitational force, we've already learned this in the first few chapters of topic 4. Okay, you see, so far do you see your progress? So far you only left 3 more. Once we already covered all of them, then we are good to say that we are professional in actually understanding forces and their different properties. Okay, now I will set a timer for about 20 minutes. Wait, Okay, teachers, can you please do me a favor? Make sure in these 20 minutes they do the work assigned, which is to copy this in their book so that it's more, organized and understandable what are we actually doing every day. Okay, students, you are required to draw all of it. Draw each icon here, okay? Don't be lazy. Make sure you draw it. Let me put in full screen mode. Okay, let me. How do I? Okay, all right. So here's my timer. Okay, I'll begin now. Okay, very good. Okay, and guys done? Okay, once you guys are done, if let's say you need more time, you can actually go a bit behind and teachers, please pause that so that other students can finish it up. Okay, now I want to assign a work. Okay, now. Right. Okay, this is your homework until the next class. Okay, so open up your student workbook 6. Okay, please mark your pages, page 52, 53, 54, and 55. 4 pages again: 52, 53, 54, and 55. Okay, all right, so far so good. Okay, I hope that you guys understand what we discussed and our notes for today. Okay, now, if you guys have any questions, please feel free to email me. You know my email, yvonne@sjis.edu.my. Okay, until then, please take good care of yourselves. Thank you so much, class. Take care. Bye.